In this tutorial video, we'd like to show you how to create a calibration curve in Excel and how to solve for the unknown value. And hopefully we'll teach you a few tricks along the way of how to more effectively use Excel. So notice at the bottom here we have several different tabs. I can change and have different data on the different tabs. So here I'm just starting off with my cover page, and if I left click on this and then right click on it, I can either insert another tab, delete one, rename it, move or copy, or do various different things. But I'm just going to click on the next sheet, so sheet 1, and this is an example of what we'd like to be able to create when we create a calibration curve. Here I have the data where I have the concentration of compound X in units of molarity. Here's where we have the percent transmittance that was measured and the absorbance that was calculated based on the percent transmittance. Then we can graph the concentration versus the absorbance. So we have absorbance on the y-axis and concentration on the x. And from that we can get a trend line for our data. And we want to calculate the slope using the slope function in Excel. And we want to calculate the Y-intercept using the intercept function in Excel. And there's advantages of doing that. And one of the advantages is that if you make a change, you don't have to retype in the number. This automatically updates the slope and the y-intercept for whatever your data is over here if you have to change something. But also too, there's less rounding error. So notice that the y-intercept value here has more decimal places. Here it would be rounded off to 0.0096 because that's just what it shows. And then once we have the trend line, then using the absorbance of the unknown, we can calculate the unknown molarity. Now this is a pretty good trend line, and we can evaluate how good our trend line is using the r-squared value. And the closer the r-squared value is to 1, the better your data is. So we typically like to see something about 0.98 or 0.99, but the closer that is to 1, the more linear your line is. So let's get started. Here I've already inserted the concentrations in molarity. Now let's start adding the percent transmittance. So 79.9, 68.8, 64.2, 58.0, 54.6, and now I want to calculate my absorbance. So let's put in our absorbance title, absorbance. And I want to make that bold so that it looks nice as a title. And I just want this to all fit within the cell, so I'm just going to hover over that line and double left click, and it'll fit exactly to the absorbance length of the word. So the absorbance is calculated as the log of 100 over the percent transmittance. So in Excel, if I wanted to do a calculation, I put an equal sign. So anytime you put an equal sign, that tells Excel to do a calculation. So we're going to do equal sign log. And notice that as I start typing stuff in, it gives me different functions that I can use. But I'm just going to use log, and the log is always a base 10 if we don't specify anything else. So log, open up parentheses, and 100 divided by the percent transmit. So I'm going to click on the B2 cell, close the parentheses, and hit enter. So it does the calculation for me. So rather than typing that equation in for each one, which can take a little bit longer time, I'm just going to highlight this cell here, hover over the bottom right hand corner to say the little plus sign, left click and hold, and then drag down. So it will copy over the same type of calculation in this column. Now this is too many sig figs. There are two ways that I can fix the number of decimal places that are shown. I can either right click, format cell, change it to a number, and change it to the number of decimal places. Or I can use the button up here to change the number of decimal places. So this one increases the number of decimal places, and this one decreases the number of decimal places. Okay, so next, let's see. I'm going to go ahead and insert my graph. So I'm going to highlight my X values, my concentration, and my absorbance. Insert. I want to scatter graph. And I don't want it to connect the lines for me because I'm going to insert a trend line. So I don't want the lines connected, but I do want the dots there. Now, since I don't want transmitted plotted versus the concentration, I'm going to highlight by clicking on one of the blue dots, right click, and we're going to delete. And I'm just going to highlight by left clicking and then deleting that. And so now I have my data. I need some labels in here. So I'm going to go up to Chart Tools and Layout. I'm going to add a chart title. And I'm going to change that to Calibration Curve. Now I want to add some axes titles. So let's do the vertical. I'm just going to do a rotated. And this is the absorbance. And I'm going to say this was done at 788 nanometers. I'm just making that data up. But that would have been measured at where you measured that absorbance. And then we're going to add the horizontal axis title. So that would be the concentration. Or let's just put molarity of X. Notice how this is kind of small. I can move this around and I can go to the home page and I can increase the size of the font to make it a little bit more legible. But when you create your graphs, think about scaling. Make sure you create a nice descriptive title for the graph and label the axes and make sure you show the units. So absorbance versus molarity. And I'm just going to resize my graph a little bit. I'm going to move it down so I can see a little bit better. Okay. So if I want to add a trend line, I left click on one of the data symbols, then right click and add trend line. I don't want to set the intercept. I want to let it calculate its own intercept. I want to display the equation on the chart and display the r squared value. And this is going to be a linear trend line. So I can take that and I can move it wherever it's visible and easy to see. If I need to change the font size, I can. Okay. But rather than relying on the slope that's put here and the y-intercept that's here, I want to calculate it in Excel. So let's calculate my slope. So equal sign, slope, and notice how it's helping me figure out what I need to do for the slope. So slope, the known y values, so the absorbance of the known values, comma, and then the known x values, so the molarities, and then close with parentheses, and then enter. So that's the slope of my line. So notice I've got the 0.26991 and the 0.2699. Notice if I do the slope function here, I just retain all those extra decimal places when it calculated it for me. Now if I want to calculate the y-intercept, so Control B to bold, so equals, the name for this is intercept. Open up your parentheses, select your y values, comma, click on your x values and drag and hold, close the parentheses, and then enter. So there we have the y-intercept as well. We've got our nice pretty graph, and we've got our trend line, we've got our slope and our y-intercept. Now for this unknown value, so this unknown sample that I was creating the calibration curve for, I measure the percent of my unknown to be 73.3%. So I'm going to calculate the absorbance of that unknown. So I'm just going to drag this down. And there's nothing there and these to the left of that I can use, so I'm going to just delete that. And so this is the unknown absorbance. Okay, so now that I've got my unknown absorbance, I can calculate my unknown molarity, because with this trend line y equals mx plus b, y is my absorbance, so I know my absorbance. I've got my slope, I've got my intercept, so I can just solve for x. So for my unknown molarity, I'm going to tell Excel to do a calculation for me with the equal sign. And I'm going to open up parentheses, and I'm going to take my absorbance value. So I'm going to click on the unknown absorbance value, so that's C9. And I'm going to subtract the y-intercept, so that's the, if we have y equals mx plus b, I'm going to subtract the b, and then I'm going to divide it by the slope, so divide it by the slope, and then enter. So the unknown's molarity, if it has a percent transmittance of 73.3 or absorbance of 0.135, so notice if we're looking on the graph here, so that's about here, travel over to our trend line and then drop down to find the molarity. So that seems reasonable, that 0.46. Now of course this is too many sig figs, so I'm just going to adjust this so that we have the same number of sig figs as our molarity concentration. Okay, so hopefully this was helpful. If you have questions, be sure to ask. Make sure you're comfortable using the Excel that's in the computer lab, because if you're given an exam or quiz using Excel, that will be the version of Excel that you'll be using. So make sure you're comfortable with that version of Excel in the computer lab. Good luck.